Good afternoon, everyone. Today we're doing an example where we find the volume of a constant object, namely of a cone topped up by a hemisphere, kind of like an ice cream cone. Okay, so we have a hemisphere on top, we have a cone on the bottom. We know that the radius of our cone or end of our hemisphere is 6 inches. So this is from the center to the side, being a radius. We know that the slant height of our cone is 12 inches, but we don't know the vertical height of our cone, okay? So let's start off by writing the formulas we know we're gonna have to use. The volume of a cone, analogous to the volume of a cylinder. Volume of a cylinder is the area of the base times its height, right? Kind of picturing filling up the base with water. The base is a circle, and so the area of that would be pi r squared, and then filling up the cylinder with water through its height, meaning we have a volume of pi r squared times its height for a full cylinder, and a cone turns out to be a third of a cylinder. And so the volume of a cone is precisely a third of the volume of a cylinder, right? Pi r squared h, that's a cylinder, 1/3 of that for the volume of a cone. And next we have the volume of a hemisphere. So we know the volume of a full sphere, volume of a sphere altogether is 4/3 pi r cubed, and so that means that the volume of a hemisphere, half a sphere, is of course the volume of a hemisphere is half of 4/3, which is simply 2/3 pi r cubed. The rest is the same, okay? And now we're dealing with volume, so we're just picturing, maybe if you want to picture this cone being filled with liquid, we're thinking of what the capacity of the cone is to hold liquid, and so we're just going to add these two together. So again, I really like structuring my solutions so that they're easy to follow. So our total volume is going to be the volume of the cone, simply added to the volume of the hemisphere. Now I'm going to write out the formulas I'm going to use. So volume of the cone, that means 1/3 pi r squared h plus 2/3 pi r cubed, right? You can skip that step if you really want to, but I like to organize my solutions. And now we can plug in the values that we have. Now, first off, we don't have our vertical height, right? We don't know what that value is. So we can see that our vertical height and our radius makes a nice right angle triangle with the slant height, right? At any time in these kinds of problems that we can see a right angle triangle taking shape, we know what that means, that we have to do with that insinuates we have to do. So let's go ahead and find the vertical height of our right angle triangle using the Pythagorean theorem. Now, the height is not the hypotenuse, that would be the slant height, and so we know that h squared is going to be s squared minus r squared, right? Subtracting when we look for one of the shorter sides in a right angle triangle. And so we have that h squared is equal to 12 squared minus 6 squared. And now you guys have seen this many times before, I'm sure. 144 minus 36. H squared is equal to 108. So h is the square root of 108. And so we get that h is roughly, let's get the square root of 108. I'll keep 2 decimals this time. 10.39, right? The question didn't really specify how many decimal places to keep, so let's just keep 2 for no particular reason. Now, we have our vertical height of the cone, right? Which we wouldn't need for the surface area, because the surface area of the cone depends on the slant height, but for the volume, we definitely do need the vertical height of our cone, okay? So now that we found that, we can go ahead and plug in our values for r of 6 and h of 10.39. Anytime we put a value inside a variable, I like to put it in brackets to remind myself what I'm doing. And so we have 1/3 pi times r, again, is 6, h is 10.39, plus 2/3, again, a fraction is simply division. So in your calculator, you're just thinking 2 divided by 3, right? Pi times 6 cubed. And now we can run through this. Again, depending on how you round, your answer might be a little bit different than the one in the end. I'm going to do all the multiplications first. I'll leave the pi out, and then I'll multiply by pi at the very, very end, because pi is an irrational number, so the less we have to round through it, kind of the more precise our final answer tends to be. So let's go ahead and do that. So we have 6 times 10.39, and then 1/3 of that, so divided by 3, right? Multiplying by a third is the same as dividing by 3. So we can divide by 3. And now plus, now we have 6 cubed times 2 divided by 3, right? 6 cubed times 2 divided by 3. And now we have pi in both terms, so we're going to multiply by pi. And we get a final volume of 517.67 rounded to decimal places. Again, I multiplied through all the numbers without the pi's. I left the pi's outside, and then I multiplied that pi at the very end once I had factored it out of both terms. This is the decimal that I got. If your decimal was very close to this, but maybe a little bit off in the decimal places, that should not be a cause for concern. It just depends on how we round at every intermediate step. That will kind of decide where we fall into for our final answer. So I hope this helps. I hope this starts to help build connections between different shapes and different formulas that we've been using in this chapter. If you guys have any questions, comments, suggestions, please do leave a message below, and thanks for watching.